Good morning, everybody. Myself, Acharya Vishvendra, and today I'm going to discuss certain things about Hooke's law. So, Hooke's law is basically stress is proportional to strain, and it can be related as stress is equals to E into strain. So, it was observed experimentally by Hertz that if you increase the stress, then strain also increases up to a certain level, which he called the proportional limit. While in general the graph is a curved one after a certain limit, as you can see in the graph over here, up to A the graph is a straight line, then there is a curvature after this point, then we have point B, point C, point D and point D. So A here is called the proportional limit, B is called the elastic limit. Elastic limit, I mean that if you release the body, release the stress, then body will regain its natural shape. But if you increase stress or strain beyond B, then there will be a permanent deformation in the body, which is represented by the point C. Point D corresponds to the ultimate stress, and E represents the fracture point over here. So that is how a general substance behaves when it is exposed to increase in stress, how the strain varies in it. For that, we'll do a thought experiment. Just suppose you are in a lab, and in that lab there is a rubber. You see, there is a rope made up of rubber, and you attach a weight to the rubber, and you gradually increases the weight. So just observe what will happen in the rubber itself. So it will change its length as it is elastic, so there will be strain in it, and more you give stress, more strain will be there. But after a certain time it will get fractured, it will get broken. So that is how you can relate the entire perspective, you can relate the entire thing. So this is how things are being done. So we can say that for Hooke's law, stress is proportional to strain in a certain region, or in general we can say that stress is equal to into strain, where E is the coefficient of elasticity. Now stress and strain both are of three types. That's why coefficient of elasticity is also of three types. They are Young modulus, bulk modulus, modulus of rigidity. So in this way we can relate to them. But there is a special part, there is some specific part of stress strain curve which corresponds to Hooke's law, that is where graph is a straight line, which is shown here by the curve O and A. So if you increase stress or strain within this limit, so stress will be proportional to strain, and it will follow Hooke's law. But if you talk in the region from A to B, then stress is not proportional to strain, and if you release it will acquire its natural shape, so there will be no permanent strain and no permanent deformation. But if you increase stress beyond B, then there will be a point in between B and D, at which if you release the body, then it will not come back to the original shape and size. So there will be permanent deformation, which we refer to the permanent set. And there exists a certain limit which is called the ultimate stress, which can be borne by the body. And after that, strain increases even if you decrease the stress. So there is no need of increasing the stress. Strain itself increases and material starts like flowing, you see. And ultimately there comes a point E where the material breaks, which is called the fracture point, corresponded by the point E. So in this way you have seen various points, and there is one more important thing. D is called the fracture point, and there is a thing, the difference between D and E is called the it decides whether the material is ductile or brittle, metal or non-metal. For ductile materials, for metallic things, X should be large so that they can be stressed well beyond a certain limit, beyond the maximum limit. So which explains why metals are malleable and ductile.